Hello. All right. So we are now diving in to our next unit, which is over angles. Okay. So angles and triangles are one of my favorite things about geometry. So I'm super excited to get right into it. If you remember from last unit, we talked about a ray. Okay. So a ray is an object consisting of one endpoint and continuing infinitely in one direction. So think of a laser. Okay, so it starts at the actual device of the laser and it goes forever and ever and ever and ever and ever until it actually reaches something. Or think of like a sun ray. So the sun, it starts at the actual star of the sun, and then the rays shoot off of the sun to give us light, and they go on forever and ever. So it goes in forever and ever in one direction. So like this picture right here, we have X and we have Y. So how we would label this is X, Y with an arrow, with a line with an arrow on one end, and it has to be the right end. Okay, so the right hand end. Okay, so we should know this from last unit. Okay, so the reason why we're talking about array is because an angle, this is these are two definitions that you should be writing down, okay, is an object consisting of two rays called sides. So the rays that it consists of are called sides, with a common endpoint called the vertex. Okay, so let me explain what that means. Okay, so we have one ray, sweet. Okay, so we have this ray, and we're going to label this point as C and this point as B. Okay, so an angle is just two rays together. Okay, so we're going to have another ray starting at point B but going a different direction. Okay, so now we have created an angle. Okay, so we have created an angle, and they are called the sides. So the rays of that angle that we just created turned into now the angle sides. Okay, all right. Here's a very good term, or a very important term that you need to know. The vertex. Okay, so the vertex is where that angle meets. Okay, it's where those two rays meet to create this angle right here. Okay, so you can actually name an angle by its vertex as long as it's the only angle. So notice right here, it is named by, so this right here, it is named by the vertex if it is its only angle, or with the vertex as the middle letter. So let me explain what that means. So you can either label it with angle B because that's the vertex and it's only one angle, or you can label it as angle CBA. So when we label angles, the vertex always has to be in the middle. Okay, vertex always has to be in the middle when naming angles. Okay, so for example, says name each of the following. So we have the sides. So we have side XZ. So side XZ is also a ray. So we have ray XZ. And then we have ray XY. And those two rays meeting at point X create our angle ZXY. Okay. All right. So the vertex here, remember, is where two of the rays meet, and they meet at point X. So our vertex here is X. So how you actually physically name this is by the vertex alone. So we have angle. So that's what that like slanted L is. So not necessarily an L with a, not like an L like this, but an L that has, it's slightly bent over. Means angle X. So we named it by its vertex because it is the only angle. Or you can name it like this. ZXY. Okay, because remember, the vertex always has to be in the middle. Or you can put it as YXZ. It doesn't really matter as long as the vertex is in the middle. All right, last but not least, you can also label angles by numbers. Okay, you can also label by numbers. So you can only label with one letter if it's the only angle. Only. Okay. You can always label like this as long as X is always in the middle. So not X, but the vertex, which is X. Vertex always has to be in the middle. Or you can name it by a number. So in this case, I just put a 1 there. You can label it as angle 1. So in different examples, you will see that it's labeled as numbers, okay? So you can also label angles as numbers. All right, so it says name all the angles you see in this picture. All right, so the key is to be very careful here, okay? Because you cannot label this as angle X. Because there are two separate angles here. Okay, so we have this smaller angle and then we have this bigger angle. Okay, so the three angles here that we have are angle, I'm going to highlight it with my laser, QXS. Okay, so QXS. Remember, vertex always goes in the middle. Then we have angle SXT. And last but not least, do not forget this, we also have the whole angle. So Q, so this one right here, QXT. So QXT, which I'm going to highlight in blue on the outside. Okay, so again, it says, why can't you just use one letter to name these angles? And it's because you have multiple angles here. Okay, if it's just one angle, we can label it with its vertex. But because it's multiple, because there are multiple angles in this situation, because we even have this big one right here, okay, you cannot just label it as angle X. Okay, even when you're naming the whole angle, like the big angle that's labeled in blue, you still cannot label that as just angle X, because I still technically do not know which angle you're talking about. All right, so here comes the fun part. Okay, so we are going to classify each of these angles, okay? So we have the picture. So we're going to name it. We're going to tell whether it's less than 90, more than 90, equal to 90, or 180. And we're going to classify it as acute, obtuse, right, or straight. So these are our classifications right here. So biggest thing that you need to take from this part right here is classify. So if I ask you to classify this angle, I'm asking if it is acute, right, obtuse, or straight. Okay, so let's talk about them. Okay, so in this picture, we have this little box right here. This box tells us that degree is 90 degrees. that box tells us. You cannot assume that that angle is 90 degrees without that box or without it telling you so. Okay? So without that box or without it saying angle T is 90 degrees, you cannot classify that angle as right. Okay? So how we name this angle is angle RTS because the vertex is always in the middle. Okay? Its measure is 90 degrees. So it equals 90 degrees. And how we classify that as a right triangle. Or right angle, sorry. We're going to label that as a right angle. Okay? Alright, the next one. Okay? It says that this angle is 125 degrees. So let's first name this angle. So this angle is LTC. Remember, vertex always goes in the middle. All right, so this angle is more than 90. So we are going to write more than 90 degrees. All right, how you classify more than 90 degree angles is an obtuse angle. It's an obtuse angle. Sorry, I'm weird. Okay, so however you remember it. Okay, so obtuse is more than 90. All right, so let's look at these pictures. We have a 90 degree, which the one of the rays is standing straight up. And then we have an angle that's classified as an obtuse angle because it's 125. All right, we have an angle right here that's clearly less than 90 because the 90 stands straight up. So we have less than 90 here. So let's keep that in mind. All right, we name this angle as YFI. Okay, because F is the vertex. It is obviously less than 90 degrees. So if it is a less than 90 degrees, it's an acute angle. It's an acute angle. Okay, my voice cannot get that high. When I was in choir, I was an obtuse or an alto. I almost said obtuse singer. An alto. So I cannot get my voice super, super high. But anything less than 90 is an acute angle. Okay, think of babies. They're acute. They're cute. Okay, so, and they're little, so they're less than 90. All right, last but not least, we have this angle that's going straight across. It looks like a line. Okay, so think of a line here. So looks like a line. Okay, so it looks like a line. So we still are able to name this angle. Okay, so this angle is actually angle NXS because X is the middle point. Okay, so that's technically what the angle is. That's that angle. Okay, so if we go back, this is what, if you see a straight angle, you'll always see this little curvature on top, this half circle, this semicircle. Okay. So this angle, last but not least, equals 180. It is two 90-degree angles together. So it equals 180, and this is called a straight angle. Okay? It should be pretty self-explanatory because it is a straight line. So it is a straight angle. All right. It says classify angle NOR. So we're wanting NOR. Okay, remember what this little box tells us. That little box tells us that it is 90 degrees. So if we go up here, what does angle that equals 90 degrees classify as? Well, it classifies as a right angle. So our classification for angle NOR is a right angle. Okay, last but not least, it wants us to classify as QOR. So we have QOR right here. We have this this line right here. So it wants us to classify this whole angle. Well, we just did that one. Okay. So when it looks like a line, okay, it is a straight angle. All right. These questions right here, lines that intersect that form four right angles are called perpendicular lines. Okay. So if you remember from algebra, y'all talked about parallel and perpendicular. Remember, perpendicular lines create right angles. So this is what it's asking. Lines that intersect, so that cross to form four right angles, are called perpendicular. Lines. Okay. So, like this example right here is a pair of perpendicular lines. And the sign for that, and I'm going to write it in blue so you know, is a sort of an upside down T. So that upside down T tells us that it is perpendicular. All right. 2 more terms we need to learn. And you need to write these in your notes. Complementary angles and supplementary angles. Okay? So a complementary angle are 2 angles whose measures have a sum of 90 degrees. So I have 2 angles who add together and equal 90 degrees. So angle H plus angle J. Well, angle H is 38 degrees. Angle J is 52 degrees. And those added together gets us 90 degrees. Okay, so a complementary angle is the 2 angles who add up and equal 90 degrees. So let me tell you how I remember this. If you look at the word complementary, okay, look at the C. Okay, you can turn that C, and I'm going to write it in red, hopefully you'll be able to see it, into a 9 by connecting. And now you have the C and the O together makes 90, and then you have degrees. So complementary, you can look at the first 2 letters of complementary, and it tells you that it is 90 by just connect them right here, and it tells you they're 90 degrees. Okay, so because it makes a 90. If you look, it makes a 9 right there. And then the O can be the 0. Okay, so supplementary angles are 2 angles whose measures have a sum of 180 degrees. So in this case, angle F plus angle G is equal to 180. So 72 plus 108 does in fact equal 180. All right, so how you remember this? Okay, you look at the word supplementary. Look at the first 2 letters. You have an S and a U. Well, I can turn this S into an 8. I can turn this U into an O or a 0, as you may say. Okay? And I can throw a 1 in front of that. And now I have a way to remember that supplementary equals 180. Okay? I have a way to remember that complementary means, that complementary means 90 by completing the C as a 9. And I have a way of 180 or supplementary meaning 180 by making the S into an 8 and the U into a 0. All right. So let's do these examples. I'm going to do the first one. I'll do the second one, actually, okay? Just remember what the word supplement means, okay? Supplement means, if you go back up here, supplementary means 180. I can make this S into a 180. Okay, so I need these angles to equal 180. All right, so if angle 1 and angle 2 are complements, so meaning they add and equal to 90 degrees. So I have angle 1 plus angle 2 are complements, so they equal 90 degrees. If the measure of angle 1 is 2x plus 20, okay, so we have 2x plus 20. We have the measure of the measure of angle 2, which is 3x plus 15, equals 90. Okay, so this little m right here, guys, I'm going to make a side note, means the measure of. Okay, so when I read this, it's the measure of angle 2, the measure of angle 1. Okay, so that's when I'm reading that in my head, that's what I'm saying. Okay, so now we just combine like terms. So I have my 2x and my 3x. So I have 5x together. And then I have my plus 20 plus my positive 15. And I get a positive 35. Set it equal to 90 because nothing changes on that side. Okay. So now we're going to solve as if our railroad tracks are there. All right. I need to move this 35 over with the 90 because I need to get 5x by itself. So I have to do the opposite sign. So I'm going to subtract 35. When I subtract 35, it evens out on the left side. So now I'm left with 5x equals 90 minus 35, which is 55. All right, so now I have 5x equals 55. So remember, we want x equals, okay? So we have to get rid of that 5 that's in front of it. Well, there's an imaginary multiplication sign between the 5 and the x. So we need to divide to get rid of it. We have to keep our equation balanced. So we have to do it on the other side. So x equals what 55 divided by 5 is, which is 11. All right. Don't forget to go back to the question. The question says find the measure of angle 1. So I'm going to plug my x into the measure of angle 1, which is 2x plus 20. So the measure of angle 1 was 2x plus 20. So I'm going to plug this in. So I have 2 times 11 plus 20. 2 times 11 is 22 plus 20. Okay, so the measure of angle 1 equals 42 degrees, by the way. So how would you want to find measure of angle 2? It's just an extra question. Well, you would find the measure of angle 2 because measure of angle 1 plus the measure of angle 2 is 90. Well, the measure of angle 1 is 42 plus the measure of angle 2. Set it equal 90. Well, then you just subtract 42. So the measure of angle 2 is 48. Not 48. Yes, 48. I'm trying to do that in my head. Okay. All right. So that's just how you would find your angles. But this right here is the answer, the measure of angle 1. Okay. Bye, guys.